Dear friends, Maths Aspirants is a community of mathematics students, research scholars, postdoc fellows, faculty members across India, initiated by myself in 2017. And we used to organize several online problem-solving sessions, test series, webinars to help the students who are preparing for different national level competitive examinations. As a part of the online problem-solving session series, today we have a session on selected problems from real analysis. And we blessed to have Ms. Diya Saha to handle the session. Ms. Diya is a very active member of our group from her degree days itself. And let me introduce Ms. Diya. Diya is from Kolkata, and she did her MSc from IIT Bhubaneswar, and she qualified GATE examination in 2024 with All India rank 245. Also, she cleared CSER net with JRF, All India rank 90 in July 2023. She is currently working as a researcher in Data and Decision Science Division of TCS Research. So I'm sure that today's session will be really helpful to anyone who are seriously preparing for this type of competitive examinations. So I welcome everyone to today's event. And also I would like to express my sincere gratitude to Ms. Diya for being with Math Aspirants. I welcome everyone to this program. Welcome, Diya.
Thank you, sir, for such a nice introduction. Yes, actually, I joined Maths Aspirants while I was preparing for JAM in 2022, and it's no, I think it is 2019, and it is a great journey from there and still continuing. Today, I want to share some selected problems from, like sir said, real analysis. I have chosen the problems from previous year JAM, GATE, and TIFR questions. So I think I will share the slides. First, I will ask everyone to try for themselves and give me the answer. Then I will share the some hints of the solution if it is all right with all. So first, I want to go to the JAM questions because I think most of you are preparing for JAM. So I will first go to the JAM, then GATE, and then TIFR. So this is the first question. You can try it on your own. Yeah, many people have said convergent. So this is the right answer. I will share the solutions with some hint of the solutions, and I will move into the next question. So as we can see, the odd number of terms of the series are the even number of terms are all 0, and the odd number of terms, if we do the k tends to infinity, it will go to 0. So as from the theorem, we can see that if every subsequence of the sequence is converging to 0, then the sequence also converges, and the limit is 0. Should be 0. So D is the correct. So this is a new question. Try it on, and you can share the answers in the comment box. All right. I see in the messages many people are saying option A. Uh, can you give the answer? Can you share the answers why you are thinking it as a option A? Because A is not the correct answer. Okay, all right. I see Shagnik has shared his reason, but I am asking about the set of limit points of y. Yes, I think now you have got the answer. So I will just go to the correct answer is D. So I'll go to the for x greater than 0, the expression will be x by 1 plus x, and you can write it as 1 minus 1 by 1 plus x. So for x tends to infinity, it will go to 1, and for x less than 0, it will be minus 1. So as I have said earlier, that y is open set minus 1, 1, and if you consider the limit points, it will be closed set minus 1 to 1. So I will move to the new problem. It is from JAM 2024. Sorry about the watermarks because I have just copied it from the questions. If you are done, you can share the answers in the chat box. Yeah, sure. Many people got the correct answer. So then I will go through the most basic their names, and I will move into the next question because you have all have got the correct answer. So as you can see that the first series n is we can compare it with the 1 by n square, and we know from the p series series test of p that 1 by n to the power p is a convergent series for p greater than 2. So greater than equal to 2, so it is here n to the power p for p is 2. So and from comparison test we can say that this is n is convergent, and for pn we can I have solved this problem, I have separated them, and then I first show that n cube by 3 to the power n plus n cube is convergent. I show it through that I compared it with the series RL, that is n cube by 3 to the power n, and I showed that by ratio test it is converging. And then I move to the cos 3 to the power n by 3 to the power n plus n cube, and by comparison test I can show them that one this term is less than 1 by 3 to the power n, and if you perform the ratio test again, it will be convergent. So we can say that both an and bn are convergent. So this is the next question. We can go with a similar way. You can solve it and share the which you think as a correct option in the chat box. It is a MSQ problem, so keep that also in mind. So more than one option can be correct. All right, I will share the correct answers. Correct answer is A. So I solved this problem considering the 𝕨𝕨 function. Did you guys solve it in a different way, or like you can share with us? Okay, first I will share my method. If anyone is doing it in any other way, I will. You can share it like after the class. So this is 𝕨𝕨 function. Many people call it as a popcorn function. So it is a very interesting function. So I also shared the graph of the function here. So you can check it on the website and learn about it, because it is very important in a real analysis. The properties of 𝕨𝕨 function we need to solve our problem is that it is continuous on all irrational points and discontinuous on rationals, and has strict local maximum on all rationals. But you can see that our function, given our given function fx, is a bit different. So it is saying 1 for like irrational numbers and 0, and 1 minus 1 by t for rational numbers. So we can write our function like this, but for the 0 part, we need to like modify the 𝕨𝕨 function a bit, because here it is not like the 𝕨𝕨 function given here is not will not satisfy this equation, because then we have to modify it, like it would be 0 in for the x equal to 0 also. So then it will also be like as it is, as we can say, it is discontinuous on all irrationals. And if we like do one, it's like add 1 minus 1 or 1 with that, so it will get the similar properties. So as we can see that fx is 1 minus gx. So gx is continuous in all rationals, so it will satisfy the property here also. So we can discard that option C and option D also, because it will be if you include that 0 x is 0 for that irrational numbers in the also Th function, then you can discard the option D also. And most interesting thing is it is continuous on all discontinuous on all the rationals. So option B will be also discarded. So only A is there, and as you can see that it has strict local maximum in all rationals. So if we are subtracting it, it will get the local minima there. So you can check the proofs of this in any real analysis books on the web also if you are interested. So this is the next problem. And try it. Then I can share the answer. Please share the correct options if you are done in the chat box as you are doing for the earlier problems. Okay, Amrita has already answered. So let's wait for 2 minutes. See if anyone else has got it done. All right, I will share the answers. So Amrita is correct. It is option A and B. So first, I want to check that if G is even or not. So I'm considering F as even. So if G of minus Y, then I can get this expression like this. And as the supremum is considered for over the all real line, so I can write it as minus x, and as if is even function, so f of x can also be written as minus x, and the supremum will be same. So G is even. So option A is correct. And so the second option is f must satisfy which limit. So we are saying that the G is finite for given y. So there we can consider assuming there exists a case as that xy minus fx is less than k, and we can get, if we divide it both sides with mod x, we can get it like this. And as k is a finite number, when mod x tends to infinity, this will go to 0. So f of x by mod x is greater than y for a given y. So for every y, we can find this inequality. So f of x by mod x will tend to 0. So tend to infinity, sorry. So option B is correct. So this is the next question. This is a NAT type question, so you have to solve it. There will not be no options.
Ma'am, please one time repeat option B.
Sorry?
One time repeat option B.
Sorry, can you write it in the chat box? I am not getting it.
Please, ma'am, you repeat option B correct.
Yes, I have written option B as correct.
One time, please, ma'am.
Oh, okay.
Repeat.
Sure, I will repeat it. So here, as I said that as it is said in the question that supremum of xy minus fx is finite. So I am assuming that for a given y, there exists a case such that xy minus fx is less than k for all x. And so I am taking fx as the left side, just changing sides. So I will get the inequality as fx minus xy, fx is greater than xy minus k. So if we divide both sides with mod x, then the left hand side will be fx by mod x is greater than y x by mod x and minus 1 k by mod x. Now for when x is like positive, then x by mod x will be 1. So this will be 1, and mod x, if we do the mod x tends to infinity, because here we need to find the limit that fx by mod x tends to infinity, will it be infinity or minus infinity? So if we do that mod x tends to infinity, then we will find this term will go to 0 because k is a finite number. So it will be fx by mod x is greater than y. Now we are finding this inequality for a given y. So for every y, we can find this, and y. If you consider how much big number if we consider for y, fx by mod x will be greater than that. So this is true for all y. So fx for mod x tends to infinity, fx by mod x will go to infinity. That's what I am saying. So is it okay?
Yes, ma'am, it is okay. Thank you.
Yeah. So we will go to the next question. Yeah, if you have any doubt, please just turn on your mic and ask. I will do my best to explain. So 2 of you have already answered. I will wait for 5 minutes, 5 to 2 minutes. So see if any other people gets the answer, then I will share the correct answer. Yeah, I will go to the answer part now. So correct answer is 1. Those who have answered, they are correct. So our n by Sn term will be like this. So if we do that 1 by root n, and we can turn it again. So by Cauchy's first limit, we know that if n tends to a, then a1 plus a1 plus up to n sum by whole divided by n also tends to a. So we can see that we can say that 1 by root 2 plus 1 plus root 2 plus up to plus root n by n will tends to infinity, because root n tends to infinity for n tends to infinity. So this is 1 by this term, so it will go, n by Sn will go to 0, because this also goes to 0 and this also goes to 0. So, and we can like by you can check by you can write the Taylor series expansion, and you can check that ln 1 plus x expansion will look like this. So minus ln 1 minus n by Sn will go like this. So if we can cancel out n by Sn term there, then this will be 1. The denominator, the numerator will be 1, and the denominator will look like this. And as we know that n by Sn tends to 0 for n tends to infinity, so these terms will go to 0. So the answer will be 1. So now I will go to the next question. The next get questions. So we will go to the similar way. This is the question. You can, this is from GATE 2024. You can share the answers if you want. Okay, nobody answered till now. So I will wait for few minutes and then I will go to the solution part. Okay, so few of you are saying that the limit does not exist, but that is not correct. The correct answer is C. So I will go to the answer section. So this is our given term, given expression. So first I will do the by parts, and using by parts, the integration will look like this. I am integrating this part and differentiating this one. So this is my first and this is my second part. So this is the integration, and I'm like I'm taking the limit to the both parts, and so 1 by epsilon will go inside. 1 by epsilon will go inside, and this is the integration part. So for it now, if we keep the limits inside, then I will get for infinity e to the power minus x by epsilon, it will go to 0. So this part will be 0. This for infinity this will be 0, and for 0 we will get that 3. So this is 3, and for epsilon tends to 0, this integration will go to 0 because e to the power minus x by epsilon, this second part is goes to 0. So the answer is 3. So do any of you want another explanation? I can explain it again. If not, then I will go to the next part. Okay. I guess I will go to the next question then. This is a radius of convergence problem for power series. We'll solve it and share the answer, as it is a NAT type question. There will be no options. Okay, I did not ask about I only asked about the radius of convergence. I didn't ask about the interval where it will be convergent. So only the radius is needed. Okay, many of you have answered the questions, so I will go to the answer part. So you are correct. The correct answer is 3. So this is the formula of the radius of convergence. You can do it. You can do it with the ratio of n plus 1 by n also, but here I have gone with the n to the power 1 by n this formula, because as you can see from the question, this formula is more appropriate for this question. So for even number of terms, n to the power 1 by n will be 1/3, and for odd number of terms it will be 1 by 5. So if you take the lim-sup, it will become 1 by 3. So r will become 3. So your radius of convergence becomes 3. So I will proceed to the next problem. You can share the options. Okay, most of you have already answered, but I think sorry. So I think all of you have not got the correct answers. So I will share the correct answers. It will be option A and B. So first I will check the continuity, then we will go to the differentiable part. So it is continuous because cos x is a bounded function. So if we do the 1 minus cos x square by y square, I actually go to the problem. I approach the problem like this. So as both sides goes to 0 for xy tends to 0, so if xy tends to 0, and which is f of 0 0 as per given the definition of the function. So option D is correct. So now for the differentiability part, we first needed to check if all the partial derivatives exist. Then if all the directional derivatives exist, then we can go to the differentiability. And if we can find any contradiction in partial differentiability or directional derivatives, existence of the directional derivatives, then we can conclude about the status of differentiability from there. So as you can see, if you do it, you can see that the partial derivatives exist, but it will be 0, but for if you say consider y as mx, then you will get the answer as 1 minus cos 1 by m square, which is not unique and does not tend to 0 because m can be many things as per your choice. So it does not tend to 0. So fxy is not differentiable at 0 0. So anyone needed any further explanation in this problem?
Hello, ma'am.
Yes.
For the continuity part, we can use polar coordinate, or we can't do by using polar coordinate and all.
Yes, you can go with your approach also. I approach the problem like this. So if you want to transform the problem into the polar coordinates, you can do it.
Okay.
Yeah. So as fxy is not differentiable, so b is not true and a is also not true. Sorry, a is true, but c is also not true. So a and b are the correct options. So this is the next problem. You can share the answer. everyone is saying the answer is 6. This is the correct answer. So I approached the problem with the Leibniz integral rule. So according to this rule, but here our limits are constants, so we do not need to consider this first two terms. We only need to consider this one. So that's what I did. G dash x is equal to 3 to 1 f dash x plus d dt. Now I have the integration of f dash is f, so it is fx plus 3 minus fx plus 1. So for g dash x equal to 0, g dash 0 is f3 minus f1, and as here the function, the values of f are given for x equal to 3 and x equal to 1. So this will be 6. 11 minus 5, that is 6. So the next questions are from TIFR. You can share the answer if it is when you have completed. And please note that they have not asked which statements are true. They have asked how many statements are true. So it will be nice if you can write which statements are you are considering as true as along with the option, correct option. So that will be better. Yeah, can you please also share like which statements which statements are true from the given 4 sentences? Yeah, sorry, I cannot do that. I cannot, like many people are here who cannot understand, who do not understand Hindi. So I guess English is the only option. So I will go to the answer. So correct answer is B, as all of you have said. But which statements are correct is like there are some when some people have said something and some people have disagreed with them. So I will go with my approach. If you consider that some of them are not right or you think another one is correct, you can always ask. Turn on your mic and interact. So first I want to do the check the differentiability. So f dash 0 is according to formula, this is this, and it will be 1 plus h cos pi by h for limit h tends to 0. Now this one goes to 0 as evidence here that cos pi by h is bounded by -1 to 1 and minus h, and so as both sides goes to 0, this goes to 0. So f dash 0 exists and it is 1. So option 1 is true. Now we have to check the increasing decreasing part, but as we can see that for x tends to infinity, fx tends to infinity, and for x tends to minus infinity, so we can write our x plus x square cos pi by x as like this. Now this for x tends to minus infinity, x goes to minus infinity, and this goes to minus infinity because x goes to minus infinity, cos s is a bounded function, and minus infinity plus 1, this term goes to minus infinity. So as it is a multiplication of the two terms, the whole term goes to infinity. But f of 0 is 0, as you can see from the definition of the function. So f is not increasing because for minus infinity it goes to infinity. For infinity also it goes to infinity, but for f of 0 is 0, it is not increasing for whole real line. So we have to check for the neighborhood of 0, and in the neighborhood minus epsilon to I'm taking a neighborhood minus epsilon of epsilon. So we know that there exists a case which is for k in natural numbers such that 1 by 2k minus 1 is less than epsilon due according to Archimedean property. So f of 1 by 2k is 1 by 2k plus 1 by 4k square, because cos 1 by for x equal to 1 by k cos, it will be, this term will be cos 2k pi, and cos 2k pi is 1. So we will get 1 by 2k plus 1 by 4k square, and for 1 by 2k minus 1, it will be h is 1 by 2k minus 1, and cos 2k minus 1 into pi, that is cos n pi, where n is odd, so that is minus 1. So 1 by 2k minus 1 is by minus 1 by 2k minus 1 whole square. So if you compare these two terms, you can see that f of 1 by 2k minus 1 is less than f of 1 by 2k. But 1 by 2k is less than k is greater than 2k is greater than 2k minus 1. But so 1 by 2k is less than 1 by 2k minus 1. So this is in the neighborhood of 0, it is not increasing. So from there on this option 1 is correct, and f dash, so option 3 is not correct, and option 4 is not correct. We have seen that as x tends to infinity, it goes to infinity. What minus x goes to minus infinity, it also goes to infinity. But f of 0 is 0. So only option 1 and 2 are correct. So if it is all right, I can go to the next question. Can you please share in the comment? Is it, if it is all right or not, or you can want to argue for another statement that is correct?
Ma'am, in zero's neighborhood, is f is increasing, but you show that if f is not increasing, so option 1 and option 2 both are correct.
Yes.
So the correct option is option C. So why?
Oh, sorry, I have sorry, that was my mistake. It should be option C. I will go to the next part, next question. So it is from TIFGS 2019. You can share the correct options in the chat box.
Ma'am,
Yes.
this question, can you solve the shortcut find the limit of the question?
Yeah, sure. I was just waiting that some of people are sharing the answers in the comment I was just waiting, and then I will share the answers like I have done for all the questions. I will as we go to the correct answers. So yeah, those who have shared in the comments, the correct answer is A. So here we can see the sequence is defined by xn plus 1 is equal to root to the power xn. So if we take log of log base 2 at the both sides, then we'll get log 2 xn plus 1 is equal to xn by 2. So now log 2 xn plus 1 by xn, it is root xn plus 1 is root to the power xn, and this is root to the power xn minus 1. So this is log 2 root to the power xn minus 1. And if we solve this one, this will get xn minus 1 by 2. So if x2 is greater than x1, then xn is increasing, because like as we can see here, x1 is root 2, so x2 is root 2 to the power root 2. So root 2 to the power root 2 is greater than root 2. So x2 is greater than x1. Similarly, x3 is greater than x2, because we can form a chain from this condition, and so xn is increasing. Xn is less than equal to 2 for all n, as you can see from the equation. So xn is monotonically increasing and bounded. So the limit n tends to infinity, xn exists. Sorry, I have missed to write xn here. So we are assuming the limit as n. So from this equation, we are getting log 2l is equal to l by 2. And if I take 2 at the left side, then it is 2 log 2l equal to l, and 2 log 2l is log 2l square equal to l. And so from here I am getting l square is equal to 2 to the power l. So l is 2. So as we can see from the option B is not correct, as we have proved that it is monotonically increasing. And xn does not exist is also not true, because if we know that if a sequence is monotonically increasing and bounded, then the limit exists. And limit n tends to infinity, xn is going to infinity, that is also not true, because it is 2 we have proved. So option A is correct. So is it okay? Do any of the part of the solution needs revisiting, or I will go to the next question.
Can you explain it again?
Yeah. Xn plus 1, as it is evidenced by the equation, xn plus given the definition of the equation, xn plus 1 is equal to root to the power xn. Now, if we took log at the log base 2 at the both sides, then this is log 2 xn plus 1, and at this time we can write it as 2 to the power xn by 2. Now, as we are taking log base 2, it will become xn by 2. So we can find this this relation from here, and we can now we are calculating another relation, that log 2 xn plus 1. We need to find a relation between xn plus 1 and xn, because we need to check if xn is increasing or decreasing. So our x1 is given as √2. So our x2 will be √2 to the power x1. That is √2 to the power √2. So which is greater than x1? So our log2 xn plus 1 by xn, like for x2 and x1, we can see that it is increasing. So we need to check for all n. So log2 xn plus 1 by xn is log2 √2 to the power, because xn plus 1 is √2 to the power xn, and xn is √2 to the power xn minus 1. So from here we can see that log2 is √2 to the power xn minus 1. And we can also write it is as log2 to the power xn minus 1 by 2. So this is the relation. So similarly, we can write log2 xn by xn minus 1 as this xn minus 1 minus xn minus 2. So we can find the chain of relation for all the terms of the sequence. So as we can see that x2 is greater than x1, so x3 will be also greater than x2, x4 will be also greater than x3. So xn will be greater than xn minus 1. So here, from here we can see that xn plus 1 is greater than xn. So xn is increasing. Now we have to check, now xn is less than equal to 2, as we can see from this equation, because we can see from this definition of the sequence, because all of the terms like √2 to the power √2, and if you go on like this, you can see that every term of the sequence is less than equal to 2. So xn is monotonically increasing and it is bounded. So from our theorem of Bolzano-Weierstrass, that limit of the xn exists. So we are assuming it as L. Now we have derived our relation from here. So we are using that, and now limit n tends to infinity is xn is L. So we are substituting L in these two terms, and it will be log2 L equal to L by 2. Now we are taking 2 at the left hand side of the relation. It is 2 log2 L equal to L, which is this, and 2 log2 L is L square in log2 L square. So if we further simplify it, we will get 2 to the power L is equal to L square. So from this we can conclude that L equal to 2. So as from our given like options, we can see that C and D are not true. D is also not true, because we have seen that xn is monotonically increasing. So option A is correct. Is it okay?
Yes, ma'am. Thank you.
Yeah. So I will go to the next problem. This is a true-false question. As you know that in TIFR you need to solve, like they usually give 20 true and false questions. So you can say that if this relation is true or false. The comments.
This question using a hospital rule.
Yeah, it is. We do it using L'Hopital rule. So yeah. Yes, as everyone said in the comment box, it is true. and as some person I didn't catch the name, so he has also shared that it is true. You can do it by L'Hopital's rules because it is in 0 by 0 format. So I didn't solve it actually. If anyone needs, I can go to the further explanation. Otherwise, I will go to the next question, I guess. So
Yes, ma'am. Next question.
Yeah. Okay. So this is the next question. This is also a true/false question. You can share the answer. Okay, the given answer is false. So I have found one function which like satisfies this claim, but someone has said that it is a necessary condition for the convergence of that integral. Can you please share like which theorem you are referring to? I will share the function like I have constructed. Okay. Yeah, sure, no problem. I will share the function like I have constructed. Sorry. Yeah, I have constructed this function. I used to negate this statement. As you can see that it is like from our given requirements of f, it should be a non-negative continuous function on R. So and my function is continuous and it is also non-negative. And if it like looks like triangles, and if you do the integration, it will be 2 into summation of 1 by n square. Now summation of 1 by n square is convergent, so 2 into summation of 1 by n square is also convergent. So integration is finite, but for limit extends to infinity, fx is not 0 because fn is 1 according to my definition of the function for all natural numbers. So anyone want to share another function? You can unmute yourself and share with us. Yeah, because many of people have said false. Can you share an example? Or did you use any other method to negate? Okay, in this case, limit at infinity does not exist. Why? Shakni, you have said that in that case, limit at infinity does not exist.
Sir, this question all PDF share in Telegram group.
Yeah, we will share. We will share it with the recording of this session. We will upload the recorded version of this class in YouTube. Along with that recording, we will share the PDF of the today's presentation.
Okay, sir, but last question, it is not clear.
Okay, Diya will include more explanations to that question.
Yes, yes,
Yeah.
I will look into it as there is some confusion regarding this part. I will look into it and I will share the PDF with this updated PDF with sir.
Yes, ma'am, but not last question. It is clear. Ma'am, please use any counter example.
Yeah, actually, I provided one counter example because, but as Shravnik was saying that it is for n tends to infinity, like for x tends to infinity, fx does not exist. But in the problem, as you can see that the condition is it should be finite. But I guess I thought that the question, like my given counter example, is correct, and I have to look into it.
Hello, ma'am.
Yes.
Ma'am, like there are some functions like as you gave in last example. So how to like I have feeling some difficulty by checking continuity, limit and all such type of breaking function which is x is depend on n and all. Can you suggest some book or something so that we can like look at some example and so that we can able to check the continuity differentiability or something. Those are breaking at some n and all.
Okay. Actually, I followed for the real analysis theory part. I followed the 𝕗𝕚𝕪𝕒 book, and 𝕨 is also very nice. If you solve the exercises, you can find that there are many counter examples and all. So, but my idea for this problem was like this only, that for like integer parts, it should look like this, and it should go like this. So as you can see, the triangles are the height of the triangle remains 1 and the base is like shrinking. So if you find out the area of the triangles, which is integration of 0 to infinity of dt, it should be 1 by n squared. Like for this triangle at 1, at 1 it should be 1. For the triangle around 2, it should be half, 1 by 2 square, like this, and it will be sum is 1 by n square, and it is 2 into 1 by n square, so 1 by n square is finite. So that was my idea.
Okay, thank you, Diya, for this today's nice session with a nice collection of previous problems from different areas in real analysis. I think the participants were also actively engaged by sharing their answers through the chat box. Now it is time for feedback. Dear participants, you can share the feedback now.
Sir.
Yes. Yes,
Sir, any polynomial x डिग्री का सर उसकी डिग्री को देखकर उसके रूट के बारे में कैसे बता सकते हैं कि सर उसका रूट मतलब पॉजिटिव होगा नेगेटिव होगा
Okay, Diya, I'm not getting his question properly. You can answer.
Actually, sir, he is asking that if there is a polynomial and how can we say about the, like, we can get an idea about the roots of that polynomial from the degree of the polynomial itself. I guess that was the question.
Yeah, if it is of odd degree, then definitely it will have a real root. Like yes. That you can use. Because, you know, complex roots will occur in conjugate pairs. I don't know whether he is looking for that answer or not. Okay, Ankit, I think we have answered your query.
Yes, sir, I am okay. But sir, जैसे I am using the polynomial में the rule of Descartes rule of sign.
Yeah. That type of rule of Descartes rule of sign is there to identify the position of roots and like that. And of course, you can use intermediate value theorem. So such kind of things can be used.
Yes, sir.
Okay, thank you, Ankit. Others, if you have any doubt, you can share it now. Otherwise, you can express your feedback.
Good evening, sir.
Yeah, it's Kirtana.
So, I'm Kirtana and I'm studying in PSG College of Arts and Science, Coimbatore. So, we have real analysis paper this semester, and in the beginning it was quite easy because we were learning basic stuff, but towards the end, when we had this chapter called Sequences and Series, I started to feel like it was a bit difficult to understand. So today's class, all the questions, they felt kind of tricky. But later when ma'am showed the answers, it actually felt very easy. Like in certain questions, ma'am used the fact that trigonometric functions, like in one question, she used the fact that cos is bounded between -1 and 1 to easily come to an answer in one of the functions questions. So overall, I felt like it was a good choice of questions because when we look at it, it's not something which we are able to suddenly solve unless we have a lot of experience solving such questions. But when we move on to the answer, it feels very simple. It was very easy to understand, and I think the class itself was taken very well. So thank you so much, ma'am, for the wonderful class and the wonderful questions.
Yeah, thank you for your nice feedback also. I have as I have said in the start of the session, this is my first time conducting such problem. I have not taught anything before. I was a student. I participated as a student before, but this is the first time I have participated as a conducting the session. So thank you for your feedback.
Thank you, ma'am.
Good evening, ma'am. I'm Isha, and talking about the session, it was really nice. It actually covered all somewhat easy question and a bit tougher and more tougher. Like you selected the best questions from the previous years, and it was really nice. Like when we see the question, for some questions I got the idea, but for the rest I didn't get it. but it was another way of like thinking that was what to say. Yeah, I got from your hints actually. So it was really nice. And thank you for the session. Thank you, Vinod sir, for arranging this.
Thank you, Isha.
Thank you, Isha, sorry.
Hello, sir.
Yes.
Sir, I am 𝕃𝕚𝕧𝕗. It is my last year BSc.
Okay.
Sir, today class is a very nice question, and ma'am explain it is very most important question for JAM and others exam in mathematics. Today is a very most important class. I am very happy. Thank you, sir. Thank you, ma'am.
Thank you.
Thank you, Ankit. Where are you studying, Ankit?
I am, sir, preparation for JAM mathematics.
Okay, I am asking about your college. Which college you are studying?
Sir, it is my state college, sir, Uday Pratap Autonomous College in Varanasi.
Varanasi. Okay. Okay, thank you, Ankit.
Thank you.
Thank you.
Hello, ma'am.
Yes.
Hello, ma'am. I'm Akita. I'm from TMC College, Tirur, Kerala. Thank you for this wonderful class. It was really helpful. You explained each question clearly. Thank you so much, ma'am, for your valuable time with us. And thank you, Vinod sir, for conducting this class. Thank you.
Okay, thank you, Akita.
Thank you, Akita.
The others, if any of you would like to share a feedback, you can make it now.
Good evening, ma'am. I'm Vanati from PSDR Bijumon College. And thank you for this wonderful section. And the problem you solved gave an idea. And I feel more confident in my ability to apply the knowledge. And thank you for the wonderful session.
Okay, thank you, Vanati.
Thank you.
Yes, if anyone else would like to share a feedback, yeah, some of the people are sharing their feedback in the chat box.
Yes, sir.
Thank you, ma'am. I'm actually Amrita. I'm from 𝕨𝕚𝕪𝕒 College, Chennai. And it's my first time doing a session here for math aspirants, and it was really wonderful. Especially the TIFR questions were really tricky, and I just liked solving them. Thank you so much.
Thank you, Amrita. Thank you for your active participation.
Yeah.
It gave me encouragement.
Yeah, I am also noticed Amrita is actively engaged in the discussion, posting answers to almost all the questions. It's really good, Amrita. We expect you in all our such sessions. Be there as an active participant in future sessions too.
Sure, sir, sure. Thank you.
Okay, anyone else? Okay, thank you, Diya, for this today's session. And please do share me the PDF. If there are more additional things to add, you can make it and share by tomorrow or day after tomorrow. By that time, we will process the video. Along with the YouTube recording, we can share the PDF.
Sure, sir. Thank you. Thank you for inviting me. It is a great honor to me.
Yeah, Diya, as you have just completed this type of competitive examinations in last year, so you are really a nice person to handle these type of sessions. So I wish that you will handle more such sessions in our platform whenever time permits.
Sure, sir. I will try my best. It is a very great honor to me.
Okay, thank you. So let us wind up here, and Yeah, good night. Bye.
Good night. Good night, all.